The broadcast is now starting. All attendees are in listen-only mode.
Okay, hello everybody, it's Piotr Doletsky here. We are just waiting for a few more people to join us, and we will be starting within the next couple of minutes. So just please bear with me. Once again, good afternoon everybody, and welcome to today's webinar on network access and network concepts for DVRs. My name is Piotr Doletsky. I am the National Product Manager CCTV at Alarm Corp, and I am based in our Mount Waverley office in Melbourne, Victoria. So as we already have a number of people joined us, I will start the webinar, and those who will join us later can still do so. Okay, before we get into the actual contents of the webinar itself, let's just go through a little bit of housekeeping. You should now all be seeing this GoToWebinar screen here as shown on the slide. Now, you will all be muted for the duration. However, I would like to draw your attention to the hand icon. This is just to, you can use this to raise or lower your hand. Can I ask you all now just to please raise your hands just to verify that you can actually hear me, just by clicking on that icon? Okay, great. I see a few hands going up. If you can put them down again, and we will continue. Next, you can see the microphone icon. Now, for the duration of this presentation, you will all be muted, and we will see how we go with regards to questions. There is a fairly large participation rate in this webinar, so I would think when we go to the questions at the end, we will get you to type in the questions, which brings me to my next point. Down here in your toolbar, you can see the questions tab. As I go through the presentation, please feel free to type in any questions, and then you can either send them at once or send them at the end using the send button. And at the end of the presentation, I will go through all of the questions in received order. So that should just make it for a smoother process. Okay, with that in mind, let's begin. Today's webinar is on network concepts for DVRs, and with an emphasis on remote connection basics. What I have here is a fairly simple network diagram showing a typical home or small business network, also known as a private network, in which we have a few devices already. We have a PC, we have another laptop, we have a network printer, and we want to add a digital video recorder, all connected to an ADSL modem router, and we want to be able to access that DVR with a remote computer or a remote smartphone. And the purpose of today's webinar is to actually go through some of the things that need to be set up in order for that to happen. So now some of you are familiar with network basics already, but let's just recap a few things for everyone's benefit. IP address. Every device on a computer network must have a unique IP address. Typically, the addresses we deal with on DVRs is something like a 192.168.1.1. Next, we have the subnet mask. Subnet masks are used to segment a network. I would say 9 times out of 10 when we're dealing with DVRs, we will be dealing with a subnet mask something along the lines of 255.255.255.0. Next, we need to talk about the concept of a private network. A private network is generally a small network limited to a single home, limited to a single small office or a small business. So it's usually within a organization. Important to note, computers within the private network can see each other. And the private IP address is the IP address of a device that's within the private network. The main point is that a private IP address is not directly reachable from a public network. Now this brings us to the concept of a public network. The public network is also known as the Internet, and the key thing about the Internet, every IP address that's on the Internet is visible to everyone else that's also on the Internet. So the public IP address is basically the IP address of a device that's directly connected to a public network. And the main benefit of having a public IP address is that that address is reachable from anywhere, which, if we want to do a remote access into a DVR, is a point of some importance. The default gateway, or the gateway, is the entry or exit point into a private network from the outside. Next, we need to talk about the concept of ports. A port is an additional means of addressing network traffic. The best analogy to a port is subdivisions on a block, for example, 52A, 52B, 52C Smith Street. The main benefit of having ports is that you can have multiple services running simultaneously sharing the same IP address. Finally, port forwarding is a means of allowing connectivity from a public network to a specific device on the private network. So next we will take a look at how we can obtain some of this information. Okay. First step is, if we want to put a DVR on a private network, is we need to determine the private network IP address information. Now on some networks you can get this from an IT administrator, on others you can't. So let's proceed on the basis that we don't know what the addressing is. Using the diagram before, we assume we are working from the first computer, PC1. We need to bring up the Windows command prompt by typing CMD into the after pressing the start bar. Now this screenshot that you see here shows Windows 7. If you're using Windows XP, you would press the start button, then click run, and then type CMD. Once you've typed CMD, you will see a DOS screen as shown on this slide. At the DOS prompt, we want to type ipconfig and press enter, just as you see there, and once you hit enter you will see a similar bit of information to that shown here in the information below. Okay. Now, once we hit enter, we need to look at what this information actually tells us. Let's look at this line here, IPv4 address, which is 192.168.72.26. This is the IP address of the computer that we are working from. Next, we see the subnet mask, which is 255.255.255.0, and the next bit of information that we want is the default gateway, which, as you can see here, is 192.168.72.1. Now, if there are other computers on the network, we need to repeat that at the other computers as well. The main benefit that we'll have is that this tells us the IP address range that is already in use on this network. Okay, next step, we need to determine the public IP address of our network. So we start Internet Explorer on the PC1 as shown before, and into the address bar we type www.whatsmyip.org, and then we press enter. And you should see a similar screen to that what we have in this screen grab. In this example, my public IP address is 61.95.53.82, and we need to write that down. Now, this is the IP address that you will need to enter into your remote computer or remote smartphone in order to access the DVR that you are about to add to your private network. So this is a very, very useful bit of information that you can get from a free service on the internet. Okay, now we've done a bit of information. Let's map out the network again. We have worked out that our PC1 has this IP address. Let's say we've worked out that the other laptop has got an address that's 192.168.72.30. And let's say that we've worked out that our network printer has got an address of 192.168.72.15. We've also worked out that our default gateway has a private address of 192.168.72.1 and that its public address is 61.95.53.82. So oops. Okay. Oops. Okay. Right. And the next step is we need to work out the DVR, the IP address for the DVR. And excuse me, we just had a few minor technical glitches. Okay. So how do we do that? We bring up the MS-DOS prompt again on computer 1 and we type ping IP address. Now in this example I'm saying ping 192.168.72.100 and we should see a similar screen. In this case we have a reply from bytes equals 32. Now what this tells us is that this address 192.168.72.100 is already used, which means we cannot use this IP address for the DVR. We need to try another address. So let's say in this example we tried address 192.168.72.200. We tried pinging that address and notice that now we see destination host unreachable. So if we get a result from a ping request such as destination host unreachable or request times out, that means there is no device at this address. It means that address is free and we could use this address for the DVR. So now we are in a position to enter the IP address into the DVR itself. Now the example here shows the configuration screen of a Interlogix TrueVision TVR10. Other DVRs will have a similar menu screen. The information might be presented slightly differently, but the basics are the same. So we enter the IP address, we enter the subnet mask, we enter the gateway, we take note of the port that the DVR is using by default. That will be important for later. And once that's done, we hit confirm. Now, when you hit confirm, depending on the DVR, some DVRs may need to reboot. Others will simply restart the network card. So that can vary by DVR. If it does need to reboot, that can be normal. Okay. Next step, we want to verify that the DVR is connected to the private network. And to do that, we need to connect the DVR to the modem router with a LAN cable. Now, this may seem an interesting point, but at this stage, virtually no security DVR is wireless. They all need to be hardwired. That's just worth remembering. So we've connected our DVR, we've configured its IP address, and so once again, we want to start up the command prompt. We type ping DVR IP address, and we should now get a successful reply. At that point, we verified connectivity on the network. We can start the Internet Explorer browser, and we can type the DVR IP address into the address bar. Now, depending on which version of Windows you are running, you may get a number of security warnings about ActiveX or needing to download certain files. Acknowledge those. Log in with the username and password you have configured, and if all goes well, you now have verified that the DVR is online and is reachable within the private network. And the screen grab below shows you the web browser view from a TrueVision TVR10. Now, I mentioned earlier that we may need to acknowledge any security warnings. So let's look at that next. What happens if you do need to change your security settings within Internet Explorer? Now, in order to do that, you will generally need to be logged in as the administrator or the local administrator on the PC. So, security warnings. One of the easiest ways to do this is to set up your private DVR IP address as a trusted site in Internet Explorer. Now, how do we do that? We bring up Internet Explorer, we click on Tools, and then we go Internet Options, and we see the following screen. We need to click on the Security tab. We click on Trusted Sites. We then click on Sites, and into that screen we manually type in the IP address of the DVR that we want to add. We also, remember, uncheck the requires server verification HTTPS box. Once you've done all that, then remember to click OK. Now at this point, the next time you connect to the DVR from within that computer, you should no longer get any security warnings, because Internet Explorer now knows that this DVR is on the trusted site. So the next step is we need to set up port forwarding within the modem router itself. And this will enable us to connect to the device remotely. Now, port forwarding establishes the link between the private network IP address and the public IP address. This is also known as network address translation, abbreviated to NAT. Now, unfortunately, this is often the most difficult step of the whole process. It must be done within the modem router. Now note, this may require help from either the building owner, the IT manager if there is one, or even the internet service provider. You need to check this. The reason this is often difficult is on some internet services, the actual ISP provides the modem router to the end user. In other words, the end user may not have the login details into the router, and it may be necessary to get the ISP provider, e.g. BigPond or IINet or TPG, to help with this step. If it's the user's own modem router, they generally have the login details. Now we see there an example of port forwarding. This is actually out of one of our routers in one of our offices that shows the devices we have online. Now you can see here we have multiple DVRs all sharing the one single public IP address. Notice that each of the DVRs has got a different private IP address, and notice also that each device has been allocated a different port number. Now once again, this step can be the hardest, and unfortunately it will vary. It will depending on what you have, whether it's a Netgear, whether it's a D-Link, whether it's a Linksys, whether it's a Cisco router, and also depending on model. So you will normally need to refer to the user manual of the modem or ADSL modem router in question. However, the good news is, once this is done, you are now ready to connect remotely to the DVR. Okay, now we are in a position to put it all together. We know the IP addresses of all of the devices on our network. And we are now in a position to connect. Okay, next step is connecting to the DVR from the public network. Now in order to do this, we need to configure the remote device. Now this may require the installation of software or applications. For example, if we want to use a remote computer to connect to a TrueVision DVR, we need to install the GNAV package. If we want to connect from an iPhone, say to a TVR30, we already have the Safari browser on the iPhone. We don't actually need to install any devices. If we want to connect to a TVR10, we need to install the iTVR mobile application via iTunes. So here we have an example from the iTVR mobile application for connecting to a TVR10. So you can see we've entered the public IP address into the iPhone. We've specified the port that we want to use, and we've supplied the user details that we have previously set up on the DVR. If we use the Safari application on the iPhone to connect to the TVR30, and notice here we are specifying the address, and we are also specifying the port that we want to connect to within the Safari browser. Once again, we need to enter in the relevant login details. So in this case, admin for the TVR30 is configured, and whatever password we have set up. Once that's done, we can then log in. Okay, now the last couple of slides have assumed we are dealing with static IP addresses. Now, it is always best to use a static IP address for doing DVRs simply because it makes things easier. However, on some ADSL or broadband connections with some ISPs, you can only get a dynamic IP address, not a static one. Now, dynamic IP address means that the IP address, your public IP address, can change from time to time and sometimes even daily. If this is the case, you need to set up a DDNS service. Fortunately, this doesn't cost any money, it only costs a little bit of time. Log on to www.dindns.com and register/setup for your free account. Note the password, you will need it. And then go to the My Services section and add a new host service. At this point, you can pick the preferred name for your DVR. In this example, we have chosen the name alarmcorp.dindns.biz. And we can see below the setup screen from a TrueVision TVR10. So we've enabled DIN-DNS, we've selected the DIN-DNS protocol, and we need to add some more information. Okay, we are using the DIN-DNS service, so our server address is members.dindns.org. The port stays at 8000. Now, the host name is the host name we've chosen in our registration. In this case, we've chosen to call our DVR alarmcorp.dindns.biz. You could call it fredsdvr.dns.biz or stevesdvr.dindns.biz or whatever name you want to make up. You then need to enter the username and password details into the TVR10 and confirm. So at this point, we have configured our DVR to use dynamic IP addresses. Okay. Next step, let's talk a little bit about optimizing remote performance. TrueVision DVRs have dual streaming settings, so this allows you to configure two different sets of bandwidths for different network speeds. You can configure high bandwidth for streaming over the local or private network, and you can configure a lower bandwidth setting for streaming to a remote connection. Many DVRs have this feature and the setup varies a little bit. However, it is a very useful thing to configure properly. If we're talking about remote DVRs, the next thing we need to do is we need to check the available ADSL/cable speeds. For example, if we have a 1 megabit/256 kilobit ADSL line, that means that the DVR's upload bandwidth is restricted to 256 kilobits per second. So we need to configure the DVR to match this rate, because if we don't, we run the risk that it will take a very long time for the DVR to connect, and or that the responsiveness or refresh rate will be very slow. Now, fortunately, packages like GENAV allow you to cater to either a high or low bandwidth connection. We would use high bandwidth from within the private network. It is recommended that you would switch to the alternate bandwidth for connection remotely. So here we go. This is a screen grab from the bottom of a GENAV screen, and you can see at the bottom we have stream primary and bandwidth high. This is the default setting when you connect to a DVR within GENAV. However, you can pull down the primary tab and select the alternate stream, which is a lower bandwidth stream. And it is always recommended that you do this when you are connecting to a DVR remotely. Now, some experimentation and reconfiguration may be required to fine-tune this point. Okay, let's just recap some of the key points we've covered so far. Private versus public network. Be very clear which is which and where you are attempting to connect from. Are we connecting to the DVR from within the private network, or are we attempting to connect to the DVR from outside the private network? Private IP addresses. On a private network, every IP device must have a unique IP address. If we're talking about the public IP address, this may be shared between several DVRs on the one side. Port forwarding. This is used to correctly route the connections from an external PC or an external iPhone to the right DVR. Again, this is analogous to saying we want 52A, 52B, or 52C Smith Street, as opposed to just saying I want 52 Smith Street. And if we do have multiple DVRs on the one side, then typically they will all have the same public IP address. However, they will be set up to use different ports. Finally, passwords and security. Remember that once you've got a DVR online, you do want to change the default passwords and note them down, or alternately set up an additional user for remote access. And you can then use that to configure the rights as appropriate. And in fact, this is something that is possible on every one of the TrueVision DVRs, that you can set up different rights for local access and different rights for remote access. For example, you may not want the remote user to be able to control the PTZ cameras or to be able to view playback. Okay, some additional points to remember. The available bandwidth. We've already talked about throttling the bandwidth within the DVR to match the available network speed. It's also highly advisable to check what else is sharing the network. For example, we've just been working on a job with a customer where the DVR is inside a workers club / Poke Palace, and we have a whole number of poker machines that are also uploading data to their own server at specified periods during the day. So even though we might have, say, 256K of bandwidth on the ADSL link, we do not have all of that bandwidth available to the DVR. So this is something that you will need to check with the end user or the IT manager on site. Next, issues with ADSL. Streaming video uses lots of data. Depending on the bandwidth / plan that is available from the ISP, you may consume the entire plan quota. Once you exceed that, then there might be an extra cost per megabyte, or the ISP might shape the bandwidth to a lower speed until the next month. And this is something that needs to be checked with the ISP, because it does vary between providers and plans. Next, we move on to issues with smartphones. The first issue we need to be mindful of is bill shock. Viewing video uses lots of data, and again, this may get very expensive because you may use up the entire available bandwidth cap rather quickly. Smartphone issues number 2, battery life. Streaming video is processor intensive and will exhaust the phone battery sooner. I know that when I connect with my iPhone to one of our TrueVision TVRs, I can actually see the battery going down in real time. So it will have an effect on how much battery life you do have left. Smartphone issues number 3, background applications. It is recommended that when you're finished streaming from a DVR using a smartphone, either using Safari or using a dedicated application, that you manually shut down or kill the application. Otherwise, they can continue to run in the background, and that may result in you seeing issues 1 and 2. That all of a sudden your battery is getting lower very quickly, and or that you get higher than expected phone bills. Okay, some tips for driving DVRs remotely. The number of cameras will heavily impact how much bandwidth you're streaming. So the fewer cameras you select, in general, the faster will be the remote update. So the recommendation is only look at those cameras that you need at any one time. Quality. Reduce the bandwidth and all quality settings to the lowest acceptable setting. This will give you faster update and connection times. And when you consider that when you're viewing cameras on a smartphone, the screen resolution is not that high, typically you can get away with streaming QSIF or SIF remotely. You don't need to go any higher because you will not actually see any benefit on a small screen. And finally, if we're dealing with presets for if we're dealing with PTZ cameras, use presets. It is always faster and easier to send a camera to a preset on a low bandwidth connection than it is to attempt manual PTZ control. And those who have tried to control PTZs using an iPhone would know this. Now, note most PTZ cameras today have got 64 or more presets. and yet when you typically go into one of those cameras, very few are typically used. So 64 presets, use them, even if each preset is only a little bit of pan and tilt travel down from the previous. It is still much faster to simply call up preset 1, preset 2, preset 3 if you want to, for example, pan the camera along a car park or along a perimeter fence. You know, you only need to program the presets once. Okay, would you like to know more? If you would like to know more, information including brochures and data sheets may be found on our website, www.alarmcorp.com.au. You can also go to the GE Security website, which is shortly migrating to www.interlogics.com.au. I would recommend that you subscribe to the Alarm Corp Pulse to receive new product information automatically. If you register online with Alarm Corp, you can get full access to the e-commerce platform, and this includes seeing your own customized pricing as well as the ability to place orders. Highly recommended that you contact your nearest Alarm Corp representative. Ed Savaris in Queensland. You can see his email address, ecs@alarmcorp, and his mobile number. We have Bob Graham in New South Wales, bbg@alarmcorp.com.au. And we have Stephen Dinger in Victoria. He also looks after South Australia and Western Australia on spd@alarmcorp.com.au. Or if you want to contact myself, the product manager, directly, there is my direct mobile phone number and my email address, prd@alarmcorp.com.au. Okay, that more or less concludes the webinar itself. I mentioned earlier about registering online. If you register with Alarm Corp during March, you can get 10% off for your first e-commerce purchase during March. So you can see here a screen grab of our website. Simply click on create account and just follow the steps. Okay, now it's over to question time. As I said earlier, I hope you've typed a number of questions for me, and I will go through them in order. If you haven't done so, you can see at the right the questions tab. Just type the question and just remember to hit send. Okay, so where is my thing gone? Okay, let's look at questions. Like I said, I will stay online for questions as long as you have them. Okay, hang on a second. Okay, the first question is how to set port forwarding through a router behind a modem. Good question. This assumes that the modem itself has got only the one port. I would first of all refer you to the manual of the modem. If the modem itself has only got one Ethernet port that goes back to a router, then the port forwarding will need to be done through a router, and typically you will need to access the setup menu of the router itself. Although some modems will have the option to set up port forwarding within the modem. And as I said earlier, unfortunately, this does vary between modems. It depends on the model, depends on the brand. So this is one question that there is not going to be a single answer to. Okay. Right. We have a number of other questions. Just let me see if I can undock this. Okay. Is there any way around this now? Okay. There we go. Several DVRs I have networked recently require multiple ports to be configured. I did one yesterday that required me to port forward 5 ports. Okay, if that is the case, then you will need to note down all of the ports that the DVR uses and set up the port forwarding individually for each port. Now, depending on the modem router in question, with some modem routers you can specify a range of ports to be port forwarded. On others you need to specify individual ports. One early DVR that I worked with needed 3 ports to be forwarded. It needed port 80, it needed port 1024, and it needed port 1027. So it's not unusual for a DVR to require multiple ports. Okay, so I hope that clarifies that answer. And unfortunately, this will vary within DVRs. If you show earlier within the presentation that the TVR10 uses port 8000, but it also uses port 80 for the initial connection. Okay. Okay, so good. That was 3 very constructive questions so far. And I will be online for a few more minutes, but feel free if you have any other questions, go ahead and ask. Okay, here we go. Okay, the question is, does the DVR support both Mac and PC system? Good question. In the case of the TVR30, we support the Safari browser as used within the iPhone. The TVR10, the TVR40, and the TVR60, there is a dedicated iPhone application called iTVR Mobile that can be used. As far as using a PC program, GENAV can only run under a Windows system. So I can double check this, but I do not believe you can set up GENAV on an Apple Mac. Having said that, I know with some other programs you can run what's called a Windows emulator on an Apple Mac, and some programs can run under that emulator. This is not something I've tested, but if that is a requirement, that is something you might want to test. But no, in general, the requirement is our DVRs support Windows Internet Explorer and the GENAV, which is the remote management software that has to be installed on a Windows PC. And it does at this stage support Windows XP and Windows 7. Okay, but that was also a very, very good question. Okay, are there any more questions? Okay, looks like that's it. In that case, once again, thank you all for attending. I hope it's been useful to you, and hopefully I will get to see you all during the next webinar, which will be in April. And as with this one, we will send out the invitations via our normal email process. If you do want to ask about individual webinars, once again, I would encourage you to email or contact one of our account managers, Bob in New South Wales, Ed in Queensland, or Steve in Victoria, or email myself, and we will happily send you the webinar plan for the remainder of the year. We do actually are going to be running a regular CCTV webinar on usually the first or second Wednesday of each month, and so we do have planned webinars until the end of the year. Okay, if that's it, then thank you all, and hopefully I'll talk to you next time.